It is Wednesday, January 22nd, and this is the Endo meeting. And we have three topics to get at today. Leo has an announcement regarding static Hermes and lockdown ability. ZB wanted to talk about hash import implementation in the compartment mapper, and Matthew wanted to talk with Chip about the future of live slots. And so, Leo, take it.
Yep, sure. So I'll go ahead and share screen for a second. So yeah, there's an upstream pull request, which is a work in progress, which is a local eval implementation on static Hermes. So yeah, the blocker we have currently on the older version of Hermes is that the version of eval Hermes has is non-standard, which is causing a problem, but this implementation works. So I tested this by forking this branch and then cherry picking an upstream commit, which was done recently. And this fixes remove unpermitted intrinsics problem we had. And yeah, lockdown completes on this fork. And yeah, the future's looking good. So just need to fix, um, yeah, what we have
So,
currently in Hermes.
so we'll have a lockdown on Hermes for the future static Hermes and not for the legacy Hermes.
So for the legacy Hermes, we just need to, yeah, need to try and find a solution for. I think it was discussed a couple of weeks ago, right? Which I missed. I'm still working on that. Um,
I'm
yeah,
sorry,
so it'll be a temporary.
sorry I'm late, but I see we're talking about Legacy Hermes, of which I have some opinions. What is this particular thing about Legacy Hermes we're talking about?
Yeah, so eval is not supported. It's excluded from support on Hermes, but in static Hermes, there's a pull request which implements local eval.
Oh,
And local eval is direct eval, right? Like
Yes,
Yeah.
local lexical
exactly.
direct eval.
I see. Where does the term local eval come from? I've never heard that.
No.
Sure. Yeah, I mean it's essentially direct eval, but it's yeah
Th-
Hermes language. You could
This
say.
is what Hermes calls it.
Ah,
Yeah, there you go.
why?
They don't know. They just don't know. I'm trusting that they just don't know the spec language.
Okay. The other thing is that direct eval is like unbelievably harder to implement than indirect eval. And indirect eval has not significantly more mechanism once you've implemented direct eval. So why would they implement direct but not indirect?
Probably has something to do with the whole idea behind Hermes, where they are in the business of taking JavaScript programs and compiling that into something that works natively on the mobile devices.
Yeah.
And as a result, what they are running is not really JavaScript, and then eval would need to be able to run JavaScript. So it's creating a
Direct
bit of a
eval,
chicken and egg problem.
but direct eval has that same problem.
Yeah, even more so. That's why it wasn't implemented, and they did create some sort of an implementation that was capable of indirect eval. Anyway, we are hoping to avoid the problem of using eval in legacy Hermes and only ship a working lockdown capability to legacy Hermes, so we can lock down the current MetaMask mobile, and then once the Hermes rewrite, the static Hermes gets shipped in React Native, we will be able to pursue setting up compartments. I'm not in the mood of using the new function trick and trying to get that as a compartment implementation to work under Hermes.
Okay. Do you yet have a test for Hermes?
So
Um,
so yeah, this so I tested this fork on the current PR that's open. I think that's ready to go if you, Mark, and Chris are happy with it. So it's the Hermes CI PR in
The,
Endo, and yeah.
sorry, I'm not sure if that's the same question. I meant, do you have a test as to whether or not you're running under Hermes?
So that I've still not quite figured out. Obviously, Hermes has lots of differences. It's very non-standard, but
For the purpose of the change we want to do in permits, we will try to focus on detecting that the intrinsic getter that throws on fields for strict mode functions is going to be detected by triple equals, and we will be able to modify the permits, which in the next step where we introduce hash imports to the code base, to be able to then build a different implementation for Hermes by replacing part of how eval is being used. We should be able to then limit the whole mechanism of detection to the Hermes build and leave original SES without it, especially knowing that a decent chunk, if not all, of the Hermes customizations might go away.
Okay. Okay, thanks.
All right. With that, let's talk about hash import. For those just tuning in, I'm sure that you have all seen package exports at this point. Package exports are that exports directive in package.json that allows you to say that for this module specifier, use this module specifier and under these particular conditions. And in Node, you can specify those conditions on the command line with -big C. An obvious one is browser. Another one is development, for example. And these allow you to switch which implementation of a module you get under different circumstances. It's very useful for making a package that is useful either on the browser or in Node that relies on Node or browser host capabilities depending on the environment. There is a lesser known imports property that you can put inside of your package JSON that allows you to remap your internal module namespace and package module specifier namespace as opposed to remapping your exported namespace. So this is implemented by Node. It's implemented presumably by other package managers. Not package managers, but bundlers, for example, and other runtimes. We have not implemented it in the compartment mapper yet because it is so seldom used and we have not yet needed it. But it's also one of those traps where someday we're going to take a dependency on something in Agoric SDK that will run afoul of the lack of this feature support. So, we ought to implement it someday. And the forcing function that we have found is that we need this in order to have an alternate implementation behavior on Hermes for some facets internal to SES. We're using the exports directive for the same facility for XS specific behavior, but that could also be done with this with an imports directive. And with that, ZB had questions about how to implement it, I believe.
Yeah, I wanted to talk about how we would implement this. And first of all, I wanted to ask if what I'm sharing is the only documentation of this feature that you're aware of, because I spent a few minutes looking for anything outside of Node and didn't find any.
This is the only documentation that I know of for this feature, and it is not exhaustive.
Yeah. And ChatGPT is not aware of how hash dependency name even works.
Yeah, it's this is not only it's not very well socialized, it's not very well documented. It is implemented, Its edges have not been explored by the community, I don't think. So we'll have to write a lot of tests to verify what node's behavior is in order to figure out what our behavior should be.
Oh. I should be able to reach out to some people who might have something to do with it, or at least know where to look for the implementation and its tests. So I'll try to dig up all we can out of Node.js on this topic.
Well, I should note that we also haven't implemented wildcard patterns for exports or imports. And wildcard patterns necessitate a probably will require evolution in the design of compartment maps and the motion of code between subsystems, and basically a big refactor, possibly a rewrite of this subsystem. So that's something to keep into mind.
For all of the things that we don't implement, do we detect them so we can give an error that there's something present that we're not implementing, or do we just ignore them?
At the moment, we're just ignoring the wild cards. It produces terrible errors at the moment.
Okay. And the other one, the imports, we're ignoring those as well?
Yeah, those manifest as reference as linkage errors. Yeah.
Okay.
Would they really? I mean, oh yeah, because it spells hash dependency name instead of dependency name.
Yes.
Okay.
Yeah. If you're using this feature, it is evident in your code because you have import with hash as the prefix of the module specifier.
Yeah.
That will show up in your error.
Yeah. That's a good aspect of this design. We also need to figure out if nesting is involved. So if you can specify those imports in a package JSON alongside module type that is not the top level package JSON, but hopefully not.
Yeah, I forget how much nesting is supported in the exports directive. I think that you can have nested conditions, but you definitely cannot have there's no concatenation of prefixes. Yeah, I think you can nest conditions, but you cannot nest mappings.
Yeah, so getting this implemented would be somewhere in the node specific implementation in compartment mapper. So it's fairly easy to figure out where, maybe a bit harder to figure out where to start. But this is not the only change because we've published Lava Mode node built on top of compartment mapper recently and started testing it. And one of the things we discovered, thank you. Kudos to Bone Skull.
Yeah, Chris, turn on your video and please give us a bow. That was only more than a year of work. You don't have video. Yeah. No, thank you. Thank you.
Yeah, so one thing we discovered is that when you pass the option dev set to true to compartment mapper, it's going to take it seems to not only take the top level dev dependencies into account, but all dev dependencies, even transitive. Which should be impossible to occur with any package manager.
if this is the case, that is a regression for sure. And I'm prepared to believe that such a regression exists because okay, so recently I added support for the development condition, and the development condition is implied by the dev flag, and I probably screwed that up when I did that refactor. The dev flag should, yeah,
We're we're only using the condition. We're not using the dev flag.
okay. So it might simply be that we need to so the dev flag should control whether dev dependencies are folded into the solution, and it should only affect the entry package. The development condition should apply to transitive dependencies. Yeah, and having thought it through, those two features are orthogonal, and we should fix this. I think I made it so that the dev flag implies the development condition, or that the development condition implies the dev flag, one way or the other. I don't know. It's actually probably orthogonal. And
We only observed it as a behavior of Lavamode nodes, so we don't have a case that narrows it down, but it shouldn't be too difficult to come up with a test that reproduces it.
all right. Well, let's fix that. You are correct. Dev dependencies should only be folded into the entry package if dev flag is specified for the mapper.
And we have another funny detail in this problem that we're going to have to solve on our end, which is we tried to use Lavamode node to run something that's in node modules.bin. So the entry is a dependency of the project in which we were installing dependencies. So its dev dependencies will not exist because they would be transitive dependencies. So we're going to have to detect that situation and then avoid depending on any dev dependencies whatsoever. But that's on our end.
Okay. Yeah, I maintain the position that node modules.bin was ill-conceived. All right.
No, that's not it. That's not it. That's not what we're doing. It's it was the executable was a file with no extension.
True.
Oh, that's also a problem. Yeah.
Yeah.
Yeah, that's also that. Yeah, Node.js has that problem, and they fixed that. The workaround for that is to use a symbolic link to a file that does have an extension, and then you infer the module type from the physical.
So if we introduce a feature to handle bins in a more transparent way, where the user doesn't have to figure out where the bin is actually, then we will be able to read enough information to figure it out.
Yeah, you just have to canonicalize the path, I think.
We definitely have to canonicalize the path. I'm not sure if just.
Very good. All right. We're on the same page then. With that, do we feel like we've run the topic of hash imports to the ground?
I think so.
Sweet. And big thank you for snipping the sword of Damocles down and carrying it safely into a safe place to store Damocles swords. Does everybody have like a Damocles sword case for safe storage for their swords of Damocles? Anyhow,
I think having it hanging over your head is not safe storage.
yeah, indeed. Is, is it still a sword of Damocles if you put it in a locked safe? All right.
Yeah.
Matthew, what the
I think
philosophers have failed us.
I've previously expressed my desire to have a sorting algorithm called the sort of Damocles that somehow involves the use of a single thread
Oh.
in some critical
Oh,
way.
single thread. Oh my God. Oh my God. That's great.
I don't know.
Most sorting algorithms are sorts of Damocles.
Well, the thing is that what you need is something that depends delicately on actually requiring there be some point. And anyway,
Yeah.
it's just an opportunity for somebody, is all I'm saying.
Right. With that, let's hand off to Matthew for important questions.
Yeah, so I basically was trying to get a recap of the current design of the OCAP kernel and how VATs are, what the plan is for what a VAT looks like there. From what I understand, you're heavily focusing on reusing the virtual objects system. I don't know if you have any plans on supporting durable objects or if it's just virtual data.
Yes, right. Yeah. The essentially is looking upon live slots as a large repository of already solved solutions to problems already packaged. And so there's a bunch of stuff in live slots that it saves us from having to implement ourselves, including all of the mechanics for virtual objects and collections, so stores and whatnot. Yes, we definitely want to incorporate the durable object stuff. We have, you can think of the OCAP kernel as being very similar in a lot of ways to swing set, with some of the constraints that swing set has to deal with relaxed, and of course it primarily is designed to run in the browser, but a lot of there's a lot of stuff in swing set which is focused on ensuring that the replicated computation, which the chain validation model requires, that you can in fact replicate the execution of all of the VATs being managed by a kernel, and so there's a lot of hard requirements for determinism there. And we don't have those same kinds of determinism requirements because typically the cluster of VATs that is being managed by a kernel is some particular individual's cluster of VATs, and what order things happen in is whatever order they happen in, and so we don't have to worry as much about ensuring that it is some particular order such that multiple parties can run the same execution and get the same ordering. Just whatever ordering happens that's consistent with the messaging model is fine.
Right. So
But none of the mechanism that's in live slots that's that is working to help ensure that does us any harm. But it does solve a bunch of other problems for us. So there we go.
So thanks. The reason I'm asking, and where I'm still trying to understand a little bit, is what your upgrades model is and what your delivery message delivery model is. In particular, I know you don't have excess or snapshots.
Right.
So what does it look like to make a delivery into a VAT, knowing that uh, knowing that you're yeah that you don't have a previous heap that you can restore or anything like that.
Right. So well, our current plan is that there will be the sort of two different. I'm kind of extemporizing the terminology here, so don't
Yeah.
fixate overly on the words that I'm using. Um, there's sort of two different species of VATs depending on whether or not they have genuinely persistent storage available to them. And if they do not, then their state is considered to be ephemeral, and they may make use of the virtual object machinery in its sort of non-durable form, either for um, um, just sort of code compatibility issues. You have some library that's designed to work with that, and you have to rewrite it to not work with it. Or one of the other purposes that the virtual object and collection stuff in SwingSet serves is to allow you to have, in particular, sets of objects and collections which can spill to disk above and beyond whatever your available memory resources happen to be. In our case, um, that's less available, I guess you could say, because if we could spill to disk at all, then we might be able to more generally provide you with durable storage. And the distinction in SwingSet between durable and non-durable virtual objects is mostly a matter of intention. The whether something is durable or not is an artifact of whether you've chosen to make it durable and to go through the effort to code the ability to recover yourself to a sane starting state on a restart, and not whether you have the ability to actually write the bits to a persistent medium. In our case, we don't generally have the ability to write the bits to a persistent medium unless we jump through some extra hoops.
Okay,
And
that's actually very interesting. So that means you don't really have much persistence.
well, the yeah, there are several different available paths to persistent storage that are available in the browser, and they're all unsatisfactory along some dimension, but which form of unsatisfactoriness you choose is um, you know a matter of taste and a matter of what your requirements force you into. Um, the most ideal thing would be to do what SwingSet does, which is just sit on top of a SQLite instance, which writes to disk. And you can do this in the browser using OPFS, but in order to have uh, access to the synchronous file system, which OPFS makes available to you, you must run in a web worker. And it has been empirically determined that if you have more than just a few web workers, your performance goes to shit.
Yep.
And so and so we and so we're thinking in terms of, well, we can enable that, but only for a relatively small bounded number of VATs for whatever their special purpose is. Another possibility, which is a little bit more annoying, is to have the persistent state available. We have it available in the kernel, which does run in a web worker, to load the persistent state at the start of a crank, and then at the end of a crank, you essentially checkpoint all of the deltas, and all of that storage is mediated through the kernel. And of course, you could amortize this over multiple cranks if you have your nominally ephemeral VATs running for more than one crank between being blown away and having their memory state lost. Um, um, and so that the load at the start of the crank is just keep using the state you had before. Um, and that could be relatively efficient, but there's some engineering work to make that actually work, which we haven't, of course, haven't done yet. And so
Yeah.
whether we can generally make durable state available to all that is a somewhat longer term engineering undertaking. We already have the ability to run ephemeral VATs, and that's not a problem. But what you can do with ephemeral VATs is interesting, but it's obviously a much more limited uh, set of sort of available things you can do with them than you could if you could actually be persistent.
I wanted to give you a sneak peek into the direction I'm considering taking swing set and live slots.
Let me toss in one other thing, which is the potential for something like the thing that I started to work on in the interregnum between Agoric and MetaMask, which was to give each VAT its own
Right, yeah,
store, and
yeah,
then change the kernel VAT communications model
yeah.
to put the delivery queue, move the delivery queue from the kernel into the VAT, and so each VAT would just queue eagerly, and then would run it would run cranks to completion at whatever rate it could chew through them, and then we do some voodoo in the kernel to make it appear as if all of the cranks completed in order, even if they didn't.
Yeah.
And we're looking at doing something like that for the OCAP kernel, simply because this persistence model, which is at least notionally load the state at the start of the crank, checkpoint the state at the end of the crank, is very consistent with that. And we don't have to do, because we're not worried about determinism to quite the same degree, we don't have to do all the voodoo to make sure that the crank completions happen in a particular order.
All right, so sneak peek into what I'm considering. Yeah, thanks for all the detail. So what I'm considering is doing away with orthogonal persistence and rely solely on durable states. So effectively, what you end up
That's
with,
moving closer to our execution model, actually.
so effectively, what you end up with is that you end up with a VAT that runs some code that has some heap states, but the heap state is just there to go and modify durable states. So now what you really have is that, and then it can be thrown away. It's ephemeral. It's not precious. It can be thrown away between any two deliveries. So effectively, what you get is that a delivery into a VAT is really a modification of the durable states from made by the delivery, and and throwing away any heap state changes.
So the question is the computation model that the heap state between deliveries is considered to be something that you could lose, or is it considered to be something that you're guaranteed to lose?
I think in our case, it's gonna have to be guaranteed to lose, or
Okay,
else it's a little
that's
bit
easier to think
difficult.
about, but more of a pain in the ass to code in as a VAT implementer.
Yes, as a program running, the thing is that once we guarantee that you are losing your states, enabling the heap state to remain is potentially an optimization.
Yeah.
Uh,
Well, I mean, this is much more like the sort of classical traditional, like a web server or something, which is you get the HTTP request, you load a bunch of crap from the database, you do your work, you send the result back, and then every process has the attention span of a goldfish.
yeah,
Yeah,
and it's exactly what the model of Cloudflare workers is. Service worker is you can
it,
get unloaded anytime, and
and
so on.
it's also the model that the vast majority of people who are developers
Yeah,
out there in the world are used to working in. Yeah.
yeah. So we'd still be using the virtual object system to make that convenient to work in, but there it would be a lot like stricter because now that means uh, there is no heap state that you can preserve, and that solves a lot of problems. That means we don't really need to rely on the only thing we would still rely on for the modable engine is the metering, but no need for snapshotting. Snapshotting can be used as an optimization or not. Like it's unclear there.
Right.
The
There was a time where we were considering running XS in a WASM,
yeah.
and specifically just using the XS heap snapshot mechanism as a way to as essentially as a form of somewhat higher reliability, um, uh, but not actually leaning on it
Right.
for
Yeah,
deliberately
the,
retaining
the
state.
the heap snapshot, if you consider the heap goes away, that means you can just initialize your VAT, take a from build object, take a heap snapshot from like the starting point, and then now that heap snapshot is what is capable of dealing with deliveries, and you just throw it away. Like the heap snapshot doesn't change. You don't need to make a new heap snapshot after a delivery. You just throw it away and start
Right,
again from what you just
right,
had,
right.
which is kind of cool. The another advantage of this approach is that you don't need to rely on engine GC to clean things up because you know your heap is going away, so you know everything that was only heap referenced after a delivery just poof.
That's really interesting because one of the things, of course, um, in the browser is in the browser there's no graceful way to force GC, um, and so a lot of and so all you had was organic GC, and that raised the question of, well, this once again there's all of this mechanism that kind of lives um, on the um, uh, presumption that you can force a garbage collection. I saw ZB said something about that went flashing past.
Yeah.
Alert.
The
Force
way to
GC.
force GC in the browser is to alert. It's
Really?
implemented to force GC, yes.
Oh my God,
Oh God.
that's
I mean, it's
both
so.
At
wonderful and
least
terrifying.
for V8 in Chrome.
I mean, it's not something you should be doing anyway, but you can just yeah.
Oh my God.
Yeah, I was gonna
Yeah,
say
I
just
figured there's probably some horrible hack, but
No, it's
I don't.
the scheduling GC that they do so that they can maintain a good smooth rendering means that they want to use any opportunity to GC. And since alert is blocking the page anyway, it's implemented to also trigger a GC.
Interesting.
Because why not? We have time.
I think.
Okay.
Anyway, you be that as it may. Once again, the reason that we in swing set relied on being able to force GC was once again all about the deterministic replicated computational model in the face of GC, where organic GC can happen at any time, but we only choose to pay attention to garbage collection at specified moments, at which point we want everybody to have
Right.
the same answer.
And here
And we,
it is just at the end of your delivery, things
yeah,
go.
and we don't, the OCAP kernel, because we're not quite as concerned about deterministic replication. I was just figuring that we would just, whatever garbage collection happened since the last time you looked is whatever garbage collection happened. And the only question there was, is that going to be sufficient to make sure that you don't get leaks? And I suspect my intuition is yes, but I'm not deeply confident of that. But
yeah, and that's the other advantage here is that that means you can never leak through the heap because the heap goes away.
right,
That
yeah,
means if you want to do distributed garbage collection, you can do your tracing on durable data.
right,
And
right, and yes, the special case of it's hard to force garbage collection is that it's easy to force garbage collection if you define the entire heap to be garbage.
So it has a lot of energy. I mean, you still need if you are going to keep your heap between two deliveries, you still need to integrate with the engine's GC by making sure you're not going to recreate a different identity for presences and stuff like that. But that is completely orthogonal from like the distributed object model. Like that doesn't have any effect on the distributed object model. It's just like the representation inside the vat. So it's really nice. You basically take GC entirely off the path of the distributed execution model.
So this is
the heap GC. Yeah.
adding more fuel to the fire of my assertion about orthogonal persistence being an attractive nuisance. Which is
Yeah, we're definitely moving towards like
it's a nuisance, but it's attractive.
Yes.
It really is attractive, but oh well.
I mean, this is things I've been thinking of for the last few weeks. Obviously, this is a serious chunk of work, but it has these very nice properties.
So yeah, so from sort of my gut take on quick take on all of that is that general approach sounds like it's quite compatible with the direction that we're going. I'm a little concerned about the cost of reinitializing everything at the start of each delivery, but I think
for us it's not a problem because in this case it's just a process fork. So again, you have an initialized environment. You which you have done a delivery, you just fork that, do the delivery in it, and throw away the worker.
Right, and
that's actually cheaper than just
well, except if you there's the initialize, the sort of creation and initialization stuff, which is the same every time, and then there's the reacquire all of your durable state that you're actually going to work with thing, which is going to be the same. You're going to be paying that cost in any case. So And
yeah, you can really have a cache in between.
Yeah, and I guess that reopens the question of whether we might want to consider reassessing our decision to move off of excess WASM, but I don't think I have an intuition that there may be some way to differentiate. I don't know. I'll have to think about the mechanics of this some more. There may be some other things which we can do with the browser just retaining the iframe or retaining the worker and
yeah. In our case, we're not strictly limited to that. Also, like if we're confident about the metering, we're not strictly limited to having to use an excess worker either, because again, there's nothing specific to excess anymore.
Right, and obviously, there's metering is another thing that we're not particularly bothering with. I mean, metering does give you, in addition to, it gives you a way to defend against runaway VATs. But having concurrently executing iframes or whatever is also kind of sort of, because now your runaway VAT is not blocking, it's just wasting compute resources. And presumably at some point somebody could reach it and shoot it in the head externally. And once again, it doesn't have to be deterministic either. So we can look at that metering.
You can always terminate the worker, correct? Or you can unload the frame. Yes.
Yeah, exactly.
I saw Richard's mute flicker.
Oh yeah, I was just expressing appreciation for the characterization of orthogonal persistence as an attractive nuisance, and I am excited at the prospect of going to a more traditional, more direct model for dealing with state.
I'm kind of sad about that, but that's the attractive part, the attractive nuisance.
To be clear, we're keeping orthogonal persistence, but not in the same place.
Yeah, I mean, I had this kind of lingering intuition that somehow this could be made to be work in the world would be wonderful, but having bloodied my forehead on this particular thing in two separate occasions at two different companies, maybe the universe is trying to tell me something.
What was the other one?
Sorry?
So
there was
electric
communities. Yeah.
And
it was actually one of my.
Are you counting Agoric as the other one, or is there some other?
Yeah, Agoric and electric communities.
Oh, okay. Yeah.
It was actually one of my first comments when I started at Agoric and became familiar with the system. Is a discomfort with the prospect of what it entails.
Yeah. So I haven't been paying attention every moment, but just I assume since Matthew's driving a lot of discussion that the requirement that we figure out durable promises is on the way to figuring this out, and we still have a lot of the user experience of orthogonal persistence via async flow.
Yeah.
Right.
I think
we're out of time and we got to go, but really quick, yes, to confirm that this requires all state to be durable. That includes promises, and so we need to have durable promises. And the other one is we keep orthogonal persistence, but we keep it at the async flow level, which is per method invocation level, really, if you think about it.
Yeah, I think I hadn't thought about durable promises being part of this story, but obviously once you point it out, and durable promises are one of those things where we kind of sort of have durable promises. It's just they're not durable on disk. They're durable by having some other VAT hold them for you. And
Yeah, what I call a durable promise is something where you are the decider, you can hold the
Yes.
result durably.
Right,
That
right.
is what the definition of a durable promise.
Right, exactly. And so, but the fact that you can have a promise that survives your reincarnation because it's not actually your promise, at least hints at should be a solvable problem.
Oh yeah, it is. I mean, it is. It's just like,
I mean,
anyway.
and not like PhD level solvable problem, but just a little bit of annoying engineering.
Yeah, we effectively have done durable promises in userland with vows, and so it's just moving into the right layer.
Yeah, I'm
Yeah.
on board for that.
We need to run out,
Yep.
especially Richard tonight. Thanks, Chip.
All right, carry on.
Till next time, folks.